A turbocharged engine is an internal combustion engine, ICE, equipped with a turbocharger. A turbocharger is a device that uses the energy from exhaust gases to increase the amount of air entering the engine cylinders. This allows more fuel to be burned and more power to be generated from a smaller engine. How does a turbocharged engine work? A turbocharged engine works by using a turbocharger to increase the air pressure in the cylinders. Exhaust gas collection. The exhaust gases from the spent fuel are directed to the turbocharger turbine. This wheel begins to rotate under the action of the energy of the gases. Air compression. The turbine is connected to the compressor by a shaft. When the turbine rotates, it causes the compressor to rotate, which sucks in and compresses the air before feeding it into the engine. Compressed air supply. The compressed air passes through the intercooler, if present, where it is cooled, and then enters the engine cylinders. Cooled air is denser, which allows more of it to be admitted into the cylinders. Increased power. The compressed and cooled air is mixed with fuel to create a fuel-air mixture. When burned, this mixture produces more energy, which increases engine power. Pressure regulation. To avoid excessive pressure, a wastegate is used. It redirects part of the exhaust gases if the pressure in the system reaches a critical level. Features of a turbocharged engine. Turbocharged engines are efficient because they use the energy from exhaust gases, which is usually lost to the atmosphere. This makes them more powerful and economical compared to naturally aspirated engines of the same size. They are popular in passenger cars, trucks, special equipment, and sports cars, where power, economy, and environmental friendliness are important. However, such engines require more complex maintenance. The turbine and related systems, e.g. intercooler, operate under extreme conditions and require regular inspection and high-quality consumables such as oil and filters. Video about how a turbocharged engine works. The difference between turbocharged gasoline and diesel engines. Turbocharged gasoline and diesel engines have a similar operating principle, as both use a turbocharger to increase power by compressing air. However, there are significant differences between them related to the specific features of each type of engine. Fuel combustion process. Gasoline engines. Fuel is mixed with air before being fed into the cylinders, injection or carburetor. The mixture is ignited by a spark plug. The turbine helps to increase the volume of air in the mixture, improving combustion efficiency. Diesel engines. The air is first compressed in the cylinders, and the fuel is injected later. Ignition occurs due to the high temperature from compression. The turbine provides a greater volume of air, which is necessary for more efficient combustion. Turbine operating pressure engine, speed intercooler, air cooling turbine design power and efficiency. Operating characteristics. Turbocharged engines have become popular due to their ability to increase power and fuel efficiency while remaining compact. However, their use has both strengths and limitations that must be considered. Advantages of turbocharged engines. The main advantage is increased power without increasing the engine's displacement. The turbine compresses the air supplied to the cylinders, allowing more fuel to be burned per cycle. As a result, the engine produces more horsepower and torque. This is especially noticeable during acceleration, when the turbine helps to unlock the engine's potential. Economy is another important advantage. Turbocharged engines consume less fuel, especially at medium and low revs, as the turbine allows for more efficient fuel combustion. For cars, this means lower fuel consumption when driving in urban conditions or on the highway. Turbocharged engines are also more environmentally friendly, as improved fuel combustion reduces harmful emissions. Many modern cars with turbocharged engines meet strict environmental standards. Disadvantages of turbocharged engines. However, turbocharged engines have their drawbacks. One of them is the complexity of their design. The turbine, supercharger system, and related components require precise tuning and high-quality materials. This makes such engines more expensive to manufacture and repair. Turbo engines also have what is known as turbo lag, the delay between pressing the gas pedal and the moment when the turbine begins to increase pressure. Although modern systems minimize this effect, it is still noticeable in some cars, especially older models. Another disadvantage is related to the load on the engine. The turbine increases the pressure and temperature in the cylinders, which leads to additional wear on parts. A turbo engine requires high-quality oil and regular maintenance, otherwise the risk of breakdown increases. Turbine service life. Diesel engines usually have a longer turbine service life because they operate at lower speeds. However, aggressive exhaust gases require regular maintenance. Gas response. Turbocharged gasoline engines respond more quickly to the gas pedal because the turbine is designed for higher speeds. Diesel engines are slower to respond, but they provide powerful and stable torque at low speeds. Care and maintenance. Both types require high-quality oil as the turbine operates under extreme conditions. In diesel engines, it is important to keep the exhaust system clean as soot can accumulate on the turbine components. Gasoline engines. Turbocharged gasoline engines deliver more power with less displacement, high specific power, but fuel consumption is higher. Diesel engines. More economical due to better thermal efficiency, but have lower specific power. Diesel engines. Turbines are often more robust, as diesel exhaust gases have a higher temperature and aggressive composition. Gasoline engines. Turbines are lighter and more compact, which corresponds to the lighter and more compact design of gasoline engines. In diesel engines, the intercooler plays a more important role, as they often operate at high boost pressures and the air heats up more. Intercoolers are also used in gasoline engines, but they are less critical to operation. Diesel engines. They operate at lower speeds, but with high torque. The turbine is also tuned to operate in this range, providing a smooth increase in power. Gasoline engines. They operate at higher speeds. The turbine is tuned for quick response to provide a sharp increase in power. Diesel engines. They usually operate at higher turbine pressures. This is because diesel fuel requires more air for complete combustion. Gasoline engines. The turbine operating pressure is lower because gasoline ignites more easily and burns faster.
What?